let's go over the entrance slip. Okay, so if I have, whoops, helps if I kind of adjust this so you can see it better, can't I? All right, so y is greater than 1, or y is greater than or equal to, so my line is going to look like that. Did you all do that one? Feel okay with those? Okay, then I had two x's. X is greater than or equal to 2, and x is less than or equal to 4. So I had this one, and I had this one. Do we agree with that? So that means right now I'm looking at an area just in this part. And then my third line I have to solve for y. So I have 2y is greater than or equal to negative x minus 4. So y is going to be greater than or equal to negative 1/2 x minus 2. So 1, 2, down 1 over 2, down 1 over 2. Did I do that right?
No.
What did I do?
It's positive 1/2 and positive 2. Because it's a negative 2 to 1.
Oh, and that makes it flips. So that's positive. That's positive. Why was this? No wonder it was looking. So it's going to look like this. Up 1 over 2. I was going to say my boundaries were looking not right. And so that means that my 4 boundary ends up being here, which is 2, 3, and here, which is 4, 4, and then we have 1 at 4, 1, and 1 at 2, 1. How do we feel about that? Good? Okay, so then you use the function. We have f of xy is equal to x plus 3y. And I plug and chug each of the 4 points in. So my f of 2, 3 is going to be 2 plus 3 times 3. So 2 plus 9 gives me 11. The f of 4 and 4 gives me 4 plus 3 times 4. So 4 plus 12, which is going to give me 16. Do you agree with that? And then I'm going to have the f of 4, 1. So I have 4 plus 3 times 1. So 4 plus 3 is 7. And last, 2, 1. So 2 plus 3 times 1 gives me 5. Good? Do we agree with that? Okay, so what's my minimum? 5, because it's my lowest number, and that's at 2, 1. And then my maximum is going to be 16 at 4, 4. Okay, good? Easy peasy, feeling okay with those? Awesome. Alrighty then, so let's put this into real life scenarios. Sorry, gotta move the pumpkin. It's in my way. Okay, so like we talked about yesterday, linear programming is used all the time, okay, in the real world. However, real world problems and situations don't come with nice, easy equations that are automatically set up for you. So that's what we're going to look at today is to learn how to write the equations that we're going to actually use in the application. Okay? The big key to this one is to be organized. You can highlight, you can use colors, charts, tables, whatever helps you be organized. There's a whole bunch of different ways to do it, but it's whatever your learning style is, do it, okay? All right, so here's our first example. Homer Hitter takes 8 hours to trim and turn on the lathe. What's lathe mean? Anybody know? It's a thing that like smooths out the baseball bats, okay? And 2 hours to finish. Each home hitter sold makes a profit of $17. The big timber, which is another kind of bat, takes 5 hours to trim and turn on the lathe and 5 hours to finish, and its profit is $29. The total time available for trimming and lathing is 80 hours, and the total available time for finishing is 50 hours. Okay? So, first most important thing is define your variables and what do they represent. Okay? That's the most important thing anytime you're working with a word problem. So, first question. What do you think our variables are going to be? What do you think what are we even talking about? Sir?
Money and hours.
We are talking about money and hours, but what are we talking about that's even more bigger? Baseball bats. That's exactly it. Okay? So we're talking about two different types of bats. So let's make X our Homer Hitter, and let's make Y the big timber. And time and money is going to be super duper important, but we're going to be able to put that in to associate it to X the Homer Hitter and Y the big timber. Okay? So the objective quantity equation. What are we trying to find? That's the real life world, what they call it. What's the objective of any business? What's your objective? Profit. Make money, right? Okay, so we're looking for a profit. So we want an equation that's going to show this. Okay? So I'm going to say, hey, P is equal to profit. Okay, so now that means my equation is going to be my profit is equal to, well, how much profit do I make on the Homer Hitter? 17. So I have 17x. And how much profit do I make on the big timber? 29. Everybody with me on that? Does that make sense? Okay? All right. Now, the system of inequalities is where it gets a little trickier. Okay? So, let's figure out our constraints. Okay? We know, remember the constraints when we talked about it yesterday? I said that's our curfew, right? So, what curfews or constraints do we have on the Homer Hitter? Well, it takes 8 hours to trim and 2 hours to finish. That's a constraint. How much time does it take to actually manufacture it? Okay? So I'm going to make a table, and I got trim, and I got finish. Okay? And for X, which is my Homer Hitter, it takes 8 hours to trim, and it takes 2 hours to finish. Would you agree with that? Okay. For my big timber, it takes 5 hours to trim and 5 hours and 5 hours to finish. Okay? How much total time do I have available for trimming? Well, the total time for trimming that is 80 hours. So it has to be less than or equal to 80. And my total available time for finishing is 50. So less than or equal to 50. Okay. Do I have information to write an equation now? Sure. Because 8x plus 5 times y has to be less than or equal to 80. Okay. And I have 2x plus 5y has to be less than or equal to 50. Okay, now I want to think about something. It's not stated. I can't make a negative amount of bats, right? So what two inequalities should I add to my list? What's going to make, if x is my number of bats, how can I write an inequality to make sure I don't have a negative number? When x has to be greater than or equal to what? So that to ensure it's not negative, what number do I, you guys are making this harder than it is. Huh? I think somebody said it. Almost 1, but I can make 1. It's just going to be 0. It has to be greater than or equal to 0. Anything less than 0 is a negative, and you can't. I can make 0 bats that day, and that's okay. And so the same is going to be true for my big timbers. I need y greater than or equal to 0. And that, honestly, is going to be true for any of our equations. Because if you think about it, when we're graphing these, if it's real life world, it has to be in that first quadrant, right? If it has to be in the first quadrant, that makes it greater than x and greater than the y. So those are always, always, always going to be involved in it. Okay? Good so far? Okay, so today the biggest thing is we're just focusing on writing the equations. We can graph all those, which, remember yesterday we had the f of x, y equation? And you guys asked me, where did that come from? Of these equations, where do you think that comes from? What do you think? Well, we created equation 1, 2, 3, 4, and 5, right? Isaac, what do you think? Yeah, it's the first equation, number 1, because it's an equal sign and not an inequality. But number 2, it's the objective. It's what we're trying to find. So that function of f of x and y, it's always going to be your objective equation when we get into the graphing part. Okay, does that make sense? Yeah? All right, let's do another one. All sorts, and then you guys get to do 2. Yay! So excited. You guys are so awake this morning. Okay. We have a couple. We have an auto manufacturer that makes cars in factory, or trucks in the factory. Has two different shops. The first shop does the basic assembly. It needs 5 worker days per truck and 2 worker days per car. The second shop does the finishing. It needs 3 worker days for both cars and trucks. The first shop has 180 available per week. The second has 135 worker days per week. Huh? Oh, I'm sorry. Yeah. Thank you, my bad. My profit's 500 for the car, and for the truck it's 700. Okay? So, what are my variables going to be? Liz, give me one. What's one variable? What are we talking about? No, because that's what's going to give us the details. But it's because it's broken down into both the truck and the car. Look at what is the per something, okay? We're talking about and comparing our cars and trucks. Okay? So we'll make X equal to our cars, and Y is going to be equal to the trucks. Okay? All right. What is our objective? What are we talking about? Any idea? Ryder, what do you think? What are we talking about? And the whole thing, what are we looking for? Amaya, what do you think? Yeah, we're still looking for the profit. Because that's what we're talking about. All right, and so our equation is going to be profit is equal to how much profit do I make on a car? So it's going to be 500x, and how much profit do I make on a truck? 700. Good. Good on all those? Okay, so let's write our system of inequalities. Okay, let's make a table again. All right, so I know I'm talking about an X and a Y. I know I'm talking about shop 1, and I know I'm talking about shop 2. And we're going to put a thing for the constraints. Okay, shop 1. What are the constraints for the car? We need 2 per car and 5 days per truck. Do you agree with that? Okay, shop 2, I need 3 days for both the car and the truck. Okay, my constraints, I have, first shop has 180 hours available, and the second shop has 135 hours available. Everybody with me on this part? See where I'm pulling the numbers from? Good. All right, so let's write some inequalities. I got 2x plus 5y less than or equal to 180. I have 3x plus 3y less than or equal to 135. What are my other two? Yes. Perfect. And what's the other one? I have one more that I have to have.
X is greater than 3 equals to 0.
Awesome. Because those are always going to be there. Good. Making a little more sense. I, honest to gosh, actually use something very similar to this when I'm pricing my items on my menu. Honest to God, do. I put, oh, here.
It's greater than.
Oh, sorry. I am still loopy on my cough syrup, so sorry, my apologies. But isn't it great if I'm whispering and not hacking all the time? This microphone, 8th period, was like, why don't you use your mic? I'm like, oh no, how did I not remember that? All right, let's do one more, all right? Okay. Time for a different color. Stitches Inc. can make at most 30 jean jackets and 20 leather jackets in a week. All right, so first question, what are we talking about? Jackets, okay? All right, so that's what we're talking about. So that's going to be my variables. So let's make X equaling my jean jackets, and Y is going to be my leather jackets. Okay. Takes a worker 10 hours to make a jean jacket and 20 hours to make a leather jacket. The total number of hours by all of the employees can be no more than 500 hours a week. Okay? Profit on the jean is 20, and the profit on the leather is 50. All right, so what's my objective? I'm looking for profit. Okay, so my equation for my objective is going to be how much profit do they make on the jean jacket? So what's my equation going to be? 20x plus 50y. Good. You're all sitting there mathing it along with me. That's awesome. All right, so my system of inequalities. Okay, I have my x, I have my y, I have my constraints. But you know what? This time, all I know is hours. So this time, I'm only going to have the one. So and that's okay. It takes a worker 10 hours to make a jean jacket and 20 hours to make a leather jacket. And the most I can have is 500. So how many equations in my inequality system of inequalities am I going to have? 3 total. Awesome. Okay, so what's the first one going to be? Let's see. Hey, Lexi, I haven't heard your voice today. What's one of the equations going to be? Beautiful. All right, Isaac, give me another one of the equations.
You only have the one equation since you only have the one line, but
I agree with you on that. You only have the one equation because you only have the one line. But,
you have the x.
yes, always, always, always. So give me one of those.
X is greater than or equal to 0.
Perfect. And then, oh, Lexi, I drew you again. How lucky for you. Give me the last one. right, awesome. How do you guys feel about these? Feeling okay? I see head shaking yes. Awesome. I only have 2 for you to do for your homework. Okay? And look how nice I was on the first one. I kind of actually don't set it up in a table for you. All right, let me get those to you.